In this video we are going to see encoders. So in my previous videos we have seen multiplexers and demultiplexers. So in the same way encoders also same concept, like multiplexers take multiple inputs and give one output based on the select lines, right? And demultiplexer is opposite, like it will take one input and give multiple outputs, right, based on the select lines. So there is a question arise, it is a single input and it is a single output and single input, right? So there is any device which takes multiple inputs and gives limited form of outputs, or which takes limited form of inputs and gives multiple outputs. This is known as the encoders and this is known as the decoders. Okay, so from this concept we got the encoders, like it is a combinational logic circuit that converts 2 power n inputs into n output lines, like n output lines also known as binary output. So reverse of encoders is decoders. Okay, let us go with the block diagram. We will get the detailed idea on this line. Like it will take 2 power n input lines, okay, 2 power n input lines and n output lines. N output lines also known as a binary output. Okay, now here two scenarios are there. So how the 2 power n inputs convert into n output means, so first case only one input is high. Okay, any one of the input is going to 1 means it is known as the first case. So and second case is multiple inputs is high. So this is the second case, means multiple inputs are going to 1, like 1 1 something. Okay, so let us go with the first case. First case for the 4 to 2 encoder, it will have 4 inputs. 4 inputs means 2 power 2 means n, which is equals to 2, right? N equals to 2, which is the output lines, like 4 inputs and 2 outputs. In the 4 inputs only one input should be high. So this is the case one just we have discussed, right? So in such case we will get the respective binary output at the output. Okay, binary code at the output. Let us go with the truth table. What are the inputs? I0 to I3. What are the outputs? Y0 and Y1. So when I0 equals to 1, rest all are zeros, then the output will be the 0 0. Like if I1 is active means we will get the 0 1 as output. If I2 is active means we will get the 1 0 as output. I3 active means 1 1 we will get. Now based on the truth table, let us identify the where Y0 and Y1 is active means Y0 is active when I2, like I1 is high and I3 is high, like I3 plus I1 which is equals to Y0. Same way when Y1 is active when I2 and I3 is high means then Y1 we will get as 1, right? Based on this, let us draw the circuit diagram. Y0 we need to combine I3 and I1 with the OR gate, we will get the Y0. Same way I3 plus I2 we will get the Y1. This is how the circuit diagram will be. Now case 1 is finished. Let us go with the case 2. Case 2 is when multiple inputs high, then we need to go with the priority encoder. Priority encoder, by the name we can say encode, it is going to give some priority for the encoder, right? Means let us go with the definition. It will use in the scenario like if more than one input is 1 or high, okay, at the same time, then output will corresponding to the highest priority. So if multiple inputs is high means the output is depends on the highest priority simply. Okay, suppose y0 and y3 at a time high, then output is y3. See, if y0 and y3 both are 1, then the output will be the y3. Okay, this is how the priority will give, because when comparing y3 is the more priority than y0, right? So that's why the output will be y3. This is how the priority which will give to the encoder. Okay, block diagram. Here only v is extra. What is v means? V is a valid bit. So valid bit, when v is going to active means if any one of the input is active or high, then v is 1. So among any one of this one means v is going to be 1. Okay, now let us go to the truth table. Here inputs are y0 to y3. Okay, outputs are a0 and a1 and v. So let us clarify with the v. Okay, so here when we pass all zeros, then there is no active input, right? So that's why v is 0. So remaining all cases v is 1. Now when you observe what is this x means, x are the don't cares, either it will be the 0 or 1. Okay, now in this scenario we are taking it as a 1. Now when a is a1, when the a1 is going to 1 means from here onwards, right? So here onwards means it will start from the 4. See how means this is when we extend, the truth table will be like this, like 0 1 2 3. Let us write like this. So from 4 onwards it is going to start, like see here 1, where is starting from the 4, right? So from the 4 all are ones, so that's why it is the K-map of like this. Like we need to club in the 8 way of K-map. When we do so, when we simply, we will get a1 as y3 plus y2. So same way in the case 1 of the K-map simplification also, a1 in the case 1 case 2 will be same. Now where the changes we will get means for the a0 is active when the scenario, like when here the 1 passing, right? So where it starts the 1, from the 2 is starting, right? From the 2 onwards extension. Okay, so it is like it is 2 and 3, right? 0 1 2 3. So 1 1, and here from the 4th case it is missing. So from the 4th scenario, so completely 4 it is missing, 4 5 6 7 it is missing. Now 8 onwards again it's starting, right? So 8 to extension. So when we simplify this, we will get a0 equals to y3 plus y2 bar y1. Okay, v is sum of all this. Okay, sum of all this means when we club y0 to y3 with the AND gate, we will get the v. Circuit diagram, when we see this, same, a1 is y3 plus y2, a0 is, when we do so, we will get like this. V is sum of all this, like y0 y2 y1, and this is y0. Okay, when we combine with the OR gate, we will get the v. So I hope you got the idea on the encoder and case 1 and case 2. If you learned anything in this video, please do a like and support by subscribing. Thank you for watching this.